Now let's focus our attention to calculate or estimate the bare module factor. Okay, we already know how to calculate the purchase cost. So let's do that. An important thing that you need to remember when calculating the bare module cost is that it depends on the type of unit that you're dealing with. So the first step to know how to calculate the bare module cost is identify what unit are you looking at and then see what is the characteristic equation to calculate its module. So, for example, for compressors and for some equipments like the ones in this table, the bare module factor, right, is going to be something that we determine from a graph, and this graph is figure 8.18, and you should have it on your PDF with all of the graphs and tables that you need for this topic. Before we identify the bare module cost, we need to know what is the material of construction, and with that we're going to be able to get that bare module cost for the equipments located in this table. So notice that compressors and drivers, for compressors and blowers, they have a similar equation. However, the FBM will be different depending on the materials of construction for that, and also for the value, right, that we get from the graph 8.18. The other thing that I want you to notice is that these equipments, they do not depend, the bare module costs do not depend directly on the pressure. So things like evaporators and fans with electric drives, and we also have fire heaters, they do have an FP, which is the pressure factor. And we're going to talk about that later. The other thing that you have here are equations for power recovery equipment, sieve trays, valve trays, and the mister pads. And these are the actual sieves that are inside, for example, a distillation column. Also, some vessels have the mister pads at the end. So this means that the way we cost out the insides of the distillation column is actually breaking that apart, right? We have the vessel, which is not defined by any of this equation. We're going to discuss that in a moment. We have the vessel, we have the inside, we have trays, and we also have the condenser and the reboiler. Remember that condenser and reboiler, they're considered to be a heat exchanger. We're going to find equations to the bare module for that, and then the inside, which is going to be defined by this equation. And then you have, if you have a column that is packed bed, you can calculate the packing tower cost, right, using the equation here on this table. Notice that this table do not include exchangers like heaters, reboilers or heat exchangers, vessels, and pumps. Okay, so for that we're going to look at another resource. So for this particular thing, right, let's say that we are identifying an equipment that is on this list. So I'm going to go, like you say here, for number one, identification of material factor. And then the second thing we will do is to see the bare module factor for that particular equipment. So notice here, I know that I have a actual compressor or blower, and that actual compressor or blower, notice here, they're all here, compressors, and these are all of the equipment description and also the material of construction. So if I have a compressor or a blower that has an actual compressor or blower that is made out of stainless steel, I notice here that the identification number, right, the identification number for that particular equipment is given by number 5, right? And if I do that, right, then the next thing that I have to do, notice that I have for multiple equipment, drives, evaporators, fans, towers, packings. Once I identify that the identification number for that equipment and that material of construction is number 5, then I come here to this graph 8.19 and come here and read 5, right? 1, 2, 3, 4, 5. I go up and then I can estimate my bare module factor. I multiply that by the other terms in the equation and I can calculate my bare module cost for that equipment within the whole process. This is an example, right? Gathering information. We have a stainless steel centrifugal compressor. We go to identify the expression for the bare module cost, and it's given by this. The next thing I will do is go to the table 8.5 8.6 and identify the identification number for that equipment and that material of construction. We have that the identification number for this example is number 2. Then I come here to this graph and go to number 5 and identify that the bare module cost is bare module factor is around 5.75, right? We're here, number 2, around 5.75. Okay. And with that, and if I know the purchases cost, right, for that compressor, and I show you ways on how to determine that, I can already calculate the bare module cost for that equipment. Notice that because the bare module cost for this equipment is using a material of construction of stainless steel, automatically that equipment is not at standard conditions, right? So as our base conditions. So we don't need to put the C naught because it's not at base conditions. If we need to determine the one at base condition, what we're gonna do is calculate the same process, right? Having a bare module factor using 1 as the stainless steel material of construction, and if that is the case, then the bare module factor will be this. Notice that there's always, even if you're using stainless steel, there's always a cost associated with the equipment, right, to use that equipment, because you have not only the purchasing cost, but you have other factors like indirect costs and direct costs, and that are important for the installation of the equipment. So there's always a factor multiplied by the base cost, because we need to invest on installing the equipment, even that is a base conditions. The next thing is to determine continuing with the bare module factor. Now let's focus on equipments that were not located on that table. The most common ones are exchangers, vessels, and pumps, and they all have the same type of equation. Okay, so the form for the bare module for exchangers, including coolers and heaters, vessels, and pumps is described by this equation. Notice that you have 2 B's, which are constants, and you also, the constants come right for the different installation repository of data collected, right, that we gather in the tables that I'm going to be showing to you. That does depend on the type of equipment. We also have FP, which is a pressure factor, and we have FM, that is the material of construction factor. In the case of base conditions, right, what we're really calculating is FBM naught, right, because for this, the FP will equals to 1 because it's base conditions. There's no penalty associated to the pressure because it's at base conditions. And if we are using carbon steel, we can assume that FM equals to 1. That means that the bare module factor equals to the constants B1 plus B2 that depends on the type of equipment, right? We're dealing with a heat exchanger, vessel, and pump, and within the heat exchangers, vessel, and pumps, there are different types that we're going to see on the table. So we need to identify what material we're dealing with. This is important. Notice that, as I mentioned before, even if we're operating at a pressure condition, we'll always have a penalty associated on the bare module cost. We are going to always pay more than the purchasing cost because we need to install the equipment, we need to pay for direct and indirect costs, and so forth. And now in this table, we can find the values for B1 and B2. Notice that the values of B1 and B2, right, the costs associated with installation and all of the additional fees, right, for putting the equipment in the plant depends on the equipment type and more, right, in terms of what type of equipment, the description or the type of equipment within the equipment type, right? So, for example, if we have a double pie, multi-pie, we're going to have values B1 and B2 that are different if we have a fixed tube heat exchanger, a Teflon tube, floating head, U-tube. So, depending on which classification between the heat exchangers, we're going to have a different factor. The same thing, a different constant. The same thing, we have a heat exchanger as air cooler, spiral plate, or flat plate, notice that the B1 and B2 factors are different. So notice that the more expensive one, if you want to think about it, are the ones that have the higher B1 and B2 at base conditions, right? If we have base conditions, that mean that B1 and B2 are going to be, FP and FM are going to be equal to 1. Therefore, B1 and B2, you're going to add it up, and that's going to be the factor that you're going to multiply the purchasing cost for that equipment. So again, it's just like an algorithm. You just go through the tables and the equations and find out the cost. Sometimes you have to make assumptions. If they tell you that it's a heat exchanger, floating head, and they don't give you like a lot of information. I have seen like combinations. I'm not sure. I don't remember. Maybe a YouTube double pipe. Something like that, the combinations of classifications. I typically use the most conservative option, and the most conservative option is the most expensive one, right? So if my estimate is a little bit over at least one equipment, is better than I underestimated, and then I don't include everything in my analysis. So you have to make decisions based on the information that you have. Notice here that you have process vessels. So distillation column, for example, are included in towers, so it's cost out as a vertical process vessel. If you have an horizontal vessel, for example, a reflux drum, a decanter, those units tend to be horizontal. Then you come here and get the B values. And the same thing with pumps, right? You have the different type of pumps and you have the different costs associated. Notice that for pumps, basically the installation and all of the factors associated with the installations are the same, right? There's no big difference. Okay, so now what we're going to focus our attention is to gather the FP and find ways on estimating the FP and the FM in this equation. So I'm going to go through different examples for you to get this information.